Okay, class, this is a continuation from what we did, getting all the problems ready to be worked. Now, I asked you not to box in anything because we actually didn't find the angle. The angle is for this activity. We're going to search, we're going to find, using the calculator, what exactly the angle for C is going to be. Okay? So, can anyone tell me what, I already asked you this, but can anyone tell me what the opposite of addition is? Subtraction. What's the opposite of multiplication? Division. Here's my question. This is an advanced question. What is the opposite of sine? See, you might say tangent or cosine, or even one later on called cosecant. Actually, that would be the inverse of it. We are looking for the negative inverse, or sine inverse. So there is an option in the calculator that gives you that. We got to go to it. So it's underneath control, to the right of equals, go to trig. And this is in the TI Inspire CX. Okay? You're going to see the inverse sine. Okay? The inverse sine for cosine, there's the inverse cosine, and for tangent, the inverse tangent. The other 6 you don't have to worry about. Okay? These 3 over here with their inverses, you don't need to worry about right now. The only thing we're worried about is sine and its inverse, cosine and its inverse, and tangent and its inverse. And for number 3, because we're going to do all the odd ones together, it says the sine of C is equal to 4/5. Now, if you were adding and subtracting and solving for equations, you would have to use reverse PEMDAS, work backwards. If you multiplied, you would divide. If you added, you would have to subtract. I would like to find out what C is before they use the sine to get 4/5, because this is an equation. So what you're going to do, I'm going to show it to you only once, and then with the next problems, you will just go straight to it. We are going to take the inverse sine of both sides. The inverse sine cancels sine. And what are you left with? The angle C. Since we took the inverse sine of both sides, we're going to take the inverse sine of 4/5. Because we undid sine. You got to have that idea straight in your mind. The opposite of addition is subtraction. The opposite of multiplication is division. The opposite of sine is inverse sine. You're undoing the sine. So C will be equal to the answer of whatever you get here, and then you get the angle for C. So let's go back to our calculator and make sure that the inverse sine is highlighted. Click enter. And what should you put in the parentheses now? 4 divided by 5. You want to put in a fraction there by clicking control division bar, then 4/5. You can do that also. And when you click enter, you should get a number like this. It's 53.1301. I would like you to always give me, not always, I would like for you for this practice to give me the whole degree. So you're going to round to the whole degree. So I'm going to look at the number 3, then the number after it. Is it 5 or greater? No. So what is the degree for this one? 53. So the angle C is 53 degrees. So because we found out what angle C is, how many angles do we have now in the triangle? How many do you know? You know 2.
Oh, so that means you can't.
Because you have 90. Now you know what this one is. And I also want you to find out what A is equal to. You always want to know what all the angles are and what all the sides are in a triangle, especially when you're analyzing the triangles. So what do I do now to figure out what angle A is?
90 plus 53.
90 plus 53. Then you're going to take 180 and then subtract the answer, which was 143, and you get 37 degrees. You figured out the missing angles for this triangle. You only knew one, and it was the 90, but we used sine to help us find the other two. The inverse sine. When you have sides and that you know it's a right triangle, you can find inside the angle by using either sine, cosine, or tangent, or their inverses. It's pretty neat stuff. Okay? All right, number 5. Remember, we're working all the odd ones together. Says cosine A is equal to 15 over 17. How do you undo cosine? Inverse cosine of both sides. Whatever you do to one side, you have to do to the other. Cosine simplifies the inverse cosine. So angle A is equal to the inverse cosine of 15 over 17. So let's go to trig in your calculator. Go to inverse cosine. And inside the parentheses, it's going to be 15 divided by 17. And what you get? 28.0725. Round to the nearest whole angle. 28 degrees. So A is 28 degrees. What's the missing angle now? C. So take 180, subtract 90, then subtract 28 from the angle that we just got, and you end up getting 62. So C is equal to 62 degrees. It's funny. I said C, and I wanted to draw an A for some reason. All right, number 7. Are you seeing a pattern? Okay, let's just go straight to it now. Z is equal to what?
Sine.
No, the inverse sine of 3 over 5. That's the pattern. It saves us some room in these problems. Okay, go to trig. Inverse sine. 3 divided by 5. Click enter. What do you get?
37.
37 degrees because we rounded up. So it's 37 degrees. Our missing angle is X.
53.
And my man here says it's 53, so let's verify.
Number 3.
It is 53 degrees, correct. See how fast it's going now? I explained it the first 2, and now it's rolling. All right, the next one. Give me the pattern. Z is equal to what? Inverse cosine of 4 over 5. Z is equal to, okay, trig, inverse cosine, 4 divided by 5, click enter, 37 degrees. I kind of figured that because the makers of this worksheet, they really like 4 over 5 a lot. Did you notice that? That fraction came up a lot. And that was, this is like the previous problem, so X is also 53 degrees. Okay, I promised you all the odd ones, so we need to flip it over. Give me the pattern. Z is equal to inverse cosine of 4 over 5. Z is equal to, let's go to trig. 4 divided by 5 is 37 degrees. So that means X is equal to 53 again. It's interesting that the different lengths of sides can still, they're going to be similar triangles, all based on a 90, 37, 53 triangle. Okay, how about the next one? The next one's kind of different. It's 4 over 3. It's tangent. So what is the pattern? C is equal to tangent inverse, or inverse tangent, 4 over 3. So go to trig. This is the first time we get to use this one, inverse tangent. Today, I mean. It is 53. degrees.
37.
And so A is equal to
37.
37 degrees. Like I said, they really like that 4/5 and in a Pythagorean triple, the 3, 4, 5 is used a lot in this worksheet. Okay, inverse tangent for the next one. C is equal to the inverse tangent of 12/35. Click enter. What'd you get? 19 degrees. And we are missing A. So let's find that out. It's 180 minus 90 for the right angle. Then subtract 19. You get 71. Okay, number 17. Number 17 is sine z is equal to 12/37. What is the angle z going to be equal to? Give me the pattern though before you answer.
Inverse of sine.
The inverse of sine, 12/37. And I'll put it in the calculator. They've already called out the answer, but here we go. Trig inverse sine, 12 divided by 37. Give me your answer again. 19 degrees. So we're missing x, and we just did that one, so it's going to be 71 degrees. How do you feel about this? Yeah? Excellent. The next thing that I want you to do is you get to practice on working with the evens. So for the remainder of the period, you're going to finish in a really short time. I would like for you to work 2 through 18, the even numbers. And then before you leave, you can check my answers to see if you got the correct answer, okay? I haven't worked them out, but I will in a little bit.